to take a look at one last equation together. And you'll notice I've only kept part A of the directions. We're just going to find solutions between 0 and 2 pi. We certainly know how to find all solutions. But the reason I want to look at this is because it is so rich in the number of options that we have. And so I want to just do this part, but we're going to do it multiple ways. What we've been doing so far is I would look at this and say, I see two different trig functions. I see sines and cosines, and they're not connected by multiplication, so I'm not going to be able to break them into separate factors. I do see just one angle, so I'm thinking I want to use an identity to get this down to one trig function. Okay. I can use my Pythagorean identity, so cosine squared is 1 minus sine squared, and then minus sine squared equals 0. Of course, another option here would have been to replace sine squared with 1 minus cosine squared. That work is going to end up being very, very similar. Here, this becomes 1 minus 2 sine squared x equals 0. Now, with just two terms, when one of them is squared and one of them is just a constant, I'm going to just bump the squared over and isolate sine squared. So I'm going to say 1 is equal to 2 sine squared x. Sine squared x is equal to 1/2. And then I can solve for sine x by taking the square root of both sides. I just need to be very careful. Square root of sine squared of x is the absolute value of sine of x. And of course over here, that's the square root of 1 on top. That'll just be 1. And then I'll put a square root of 2 on bottom. And hopefully we've rationalized that often enough that we recognize in simplified form that's root 2 over 2. Okay. So this means that sine of x is either plus or minus root 2 over 2. Now, because I've got both the plus and the minus sign, I'm actually going to get a solution in every single quadrant. So in quadrants 1 and 2, where sine is positive, I'm going to have a solution to sine of x equaling positive root 2 over 2. In quadrants 3 and 4, where sine is negative, I'll have a solution to my other equation, sine of x is negative root 2 over 2. Okay. For all of them, this solution, the acute angle whose sine is root 2 over 2, is going to be my reference angle. Okay. And hopefully we recognize that that's going to be 45 degrees, which means it's going to be pi over 4. Okay. Notice I get 1 over root 2, which was the non-simplified version, and of course I can rationalize that to root 2 over 2. So here I'm getting pi over 4. Here that's my reference angle, so x is pi minus pi over 4, that's 3 pi over 4. Here it's my reference angle, but now it's pi plus pi over 4, so that's 5 pi over 4. And here it's my reference angle, so it's 2 pi minus pi over 4, and that's 7 pi over 4. So basically we're getting odd multiples of pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And of course, if I had asked for all solutions, we'd just add a multiple of 2 pi to each of those. Okay, so that was trying to get things in terms of just one trig function. Okay. I'm going to now show that we could get the same solutions several other ways. Now, here, I just got 2 terms on the left and 0 on the right. If I were to just add over cosine squared x equals sine squared of x, and then take the square root of both sides. Now, being very careful here again, that means the absolute value of cosine x equals the absolute value of sine x, which means cosine of x is either the same or the exact opposite of sine x. Okay. Don't need to write 2 plus or minus signs because there are really only 2 possibilities. They're the same or they're opposites. Now, that's essentially 2 equations. Cosine x equals sine x and cosine x equals negative sine x. Okay. And they both have two trig equations. Usually, we don't like to see that. We don't want to have two different trig equations, or not trig equations, trig functions in the same equation, because that makes it harder to solve. But this is a very special relationship. What angle has the same sine and cosine? Pi over 4. And so that's going to be my reference angle for any solution to either one of these. Because here, they've got to have the same sine and cosine. Here, they've got to have the opposite, but their absolute values then have to be the same. They're using the same reference angle. Okay. And that's a very special relationship. Now, if this was cosine x equals 2 sine x, I don't know off the top of my head an angle whose cosine is twice the sine. Then I would have to use some identities to try to get things to be just one trig function. But if I've got sine and cosine, and the relationship is that they're equal or opposite, I can recognize that means my reference angle is pi over 4. So cosine x equaling sine x, that's going to actually give me in quadrant 1, that would give me x equaling pi over 4. And I'd have a solution in quadrant 3. Because in quadrant 3, sine and cosine are both negative, so they can be the same. So this would give me pi plus pi over 4. That's my 5 pi over 4. Cosine equaling the opposite of sine, that's going to give me my solutions in quadrants 2 and 4, because those are the two quadrants where one of the functions is positive and the other is negative. So here I'm going to get my 3 pi over 4, and here I'll get my 7 pi over 4. But I get the same solutions. Okay. So if you're getting that very special relationship, cosine equals sine or cosine is the opposite of sine, it's okay to actually have two trig functions in your equations. Notice another way I could have gotten to that is I could have noticed, hey, that's a difference of 2 squares. So this is just cosine of x plus sine of x times cosine of x minus sine of x equals 0. It factors that way. And now, if I set each of these factors equal to 0, if cosine x plus sine x equals 0, cosine x is the opposite of sine x. And if cosine x minus sine x equals 0, cosine of x equals sine of x. So I get those same two relationships. I'm going to get my same answers. Okay, so that's just a special relationship that I wanted to point out. I'm going to show you one more option here. Again, if I add this over, I'm going to get cosine squared x equals sine squared x. Now, as a general rule, if I'm solving equations, I don't divide by expressions that have variables in them, because I don't know if I'm dividing by 0, because maybe that thing is 0. So as a general rule, I'm not allowed to just take an equation and divide through by cosine squared, because that might be 0. But in this case, I'm going to divide through by cosine squared. I'm just going to justify why I can do that. I know that if this equation is true, neither sine nor cosine is 0, because they're never 0 at the same angle. So if cosine were 0, sine wouldn't be 0, and vice versa. But if when I square them I get the same thing, that wouldn't be possible. So I'm just going to make a note, okay, because cosine squared x doesn't equal 0, and that's because sine and cosine are never simultaneously 0. They're both 0 some of the time, but never at the same angle. Now, if you're going to do that, I do want some justification of why you know it's okay to divide by that. Okay. All right. this becomes 1 equals tangent squared x. And now I can take the square root of both sides. Square root of 1 is 1. Square root of tan squared is the absolute value of tangent. And now I get tangent of x is plus or minus 1. Again, because it's plus or minus, I'm going to have a solution in every quadrant. And I can see that my reference angle again is going to be pi over 4. Okay. So that's another option that we have. So I just wanted to point that out. It's kind of neat that we've got so many options. In general, there isn't one right way of doing things. Sometimes there's a most efficient way of solving things. In this case, I'm not sure which way I think is the most efficient. It really depends on what you see. But I did want to point out that special relationship of, if you know sine is the same as cosine or sine is exactly the opposite of cosine, that's telling you your reference angle is pi over 4.